Hi, in this video, I will be demonstrating how to set Julia up on your personal computer, then how to install and set up VS Code as a powerful editor for Julia, and finally, I'll demonstrate how to install SmoQyDQMC, a Julia determinant quantum Monte Carlo package I've been developing, and how to run your first simulation using it. So to get started, to install Julia on your system, just Google Julia. You'll immediately find the language website, and then you can go here to their download link. And here you'll find a command you can run in the terminal to install the Julia language on your system. This command is for Unix and Linux style systems, so for Macs as well. If you're running on a Windows machine, simply click here and you see the comparable command for a Windows system to install Julia. So I'm on a Mac, so I'm going to copy this guy and open a terminal. And I'm just gonna paste that command in and run it. It's going to take a second to proceed with installation, just the standard installation. This is just going to take a minute or two. Um, Once it's done installing, I'm going to quit the terminal and restart the session. And once I do that, I should be able to spin up the Julia REPL environment in the terminal and verify that everything was installed properly. So let's just wait a second here. It shouldn't take very long. Okay, we're all done. As I said, I'm going to quit. I'm going to restart the terminal and then type the Julia command. And there, we verified that Julia is operating as expected. So I'm going to exit there. Now we're going to move on to installing VS Code as a really powerful editing tool for the Julia language and really any language. VS Code is one of the best editors. I would say the best editor on the market that's free. So here you again can just Google VS Code and short for Visual Studio Code. And the first option will be a website for it. And you can go to the download link and download the appropriate installer. For me, again, it's a Mac. So I'm going to install that guy. It's all installed. Go to downloads. Let's unpack this guy. Cool. I'm going to move this to my applications directory. And then I'm going to move the zip file to the trash. I don't need that anymore. And then this guy, the VS Code package, I'm also going to add it to my dock because I use it constantly. So let's start this guy up. Open. Cool. So it opened up. Let's go to full screen. It's a little bit easier to see. So the first thing I'm going to do is I'm just going to open a folder, which I'm going to just open the downloads directory so that we have like a working space. It's rather convenient. You can see the folder structure here listed on the left. But the first thing we're going to want to do is go to extensions and install some useful extensions that we will really need to make this a powerful editor for Julia. So the first one is just type in Julia and you'll see the Julia language extension, and we're going to install that. Cool. There's some other ones I would recommend installing. So for instance, if you like working with Jupyter notebooks, I would recommend downloading the Jupyter Notebook extension so you can run Jupyter notebooks in VS Code as well. So I'm just going to install that really quickly. And then there are a bunch of other ones you can install. Like I use something called Toml configuration files in my work a lot, and there's like a syntax highlighter for that guy. So I'm going to install that as well. But just explore the extensions. I encourage you to explore the extensions because there are some really handy ones here. So having done that, I want to sort of demonstrate some of the cool functionality we have with this extension. I'm going to create a new file. We're going to call it test.jl because I'm just going to play with stuff. I'm going to open it, create it in the downloads directory, and you can see it just here populated. So one really cool thing with this Julia extension is that it allows for like interactive execution. So I can do function test. Let's just create a test function that adds two numbers. Um, Very trivial. Sorry. And sorry about that. The Zoom um, meeting controls kept on popping up when I hit escape. Anyways, I can do this, and now I can try running it. And and then here's the cool thing. If I hit Shift Enter, it'll open up a Julia REPL environment and a terminal down here and execute the block of code you see above, which is very handy for quickly testing and um, benchmarking different things. Let's try that again. Maybe it didn't work the first time. Why is this not working? Okay, that just started working. I'm not exactly sure what the problem was, so let's retry that. So if I hit enter and it just executed test, I compiled it, and now I can run it and it works 1 + 2. Very nice. So that's really cool. It's a really cool environment for testing different functions and seeing how they work. So now let's move on. We next want to install SmoQyDQMC. So let's just open up a terminal here, and I will go back to the to my browser. So if you Google SmoQyDQMC.jl, the first entry you'll get is a link to the GitHub repository for the package. And if we go down, we will see some instructions for installing SmoQyDQMC. It's really easy. You just have to do add SmoQyDQMC after entering the package manager for Julia. So if we go back here, what we can do is we just open up a Julia REPL environment. If you hit the forward bracket button, you enter the package manager. To exit the package manager, just hit delete. So entering back in, I can just type add SmoQyDQMC, and we will quickly see that it installs not just SmoQyDQMC, but all of its dependencies. There are a lot of dependencies. This is a very complicated package. And this is one of the things I love about Julia. The package manager is very convenient and easy to use. It takes care of linking to all of your libraries. The Julia language also ships with built-in installations of BLAS and LAPACK for efficient linear algebra routines. It just makes everything really easy. Okay, so that it's installed SmoQyDQMC, or at least it says it does. We can test this by just doing using SmoQyDQMC. And you see that I was successfully able to import the package. So everything looks like it's working as I would hope it would. Okay, going back to the GitHub repository for SmoQyDQMC, you will see that we have links that you can follow here with either the blue badges or down here with the explicit links to the documentation for SmoQyDQMC. And the place to start is this Square Hubbard model tutorial. This is like a starting tutorial for SmoQyDQMC. It's broken into sections. And it sort of demonstrates how to put together a Julia script for running a DQMC simulation. And in this initial example, it's for the simple Square Hubbard model. Right at the top of the example, we can click this link to download a script, the script corresponding to this example. I would encourage everyone to go through this tutorial if they want to learn how to use this package, but I'm just going to skip to the bottom. Here's the command we can use to run the simulation in a quick test. The command line arguments are described in the text, but here with this command, we're going to simulate a square Hubbard model with a on-site repulsive U of 5, a next nearest neighbor hopping amplitude of negative 0.25, chemical potential of -2. We're going to simulate a 4x4 lattice at beta 4. We're going to perform 2,500 thermalization updates, 10,000 measurement updates, and we're going to write bin average measurements to file 100 times during the simulation. To really understand all of that, again, just take some time and read the tutorial. It explains everything I just described in more detail, but we're just going to copy this guy, move it over here. Note that I downloaded the Hubbard Square script, and now you see it populated in the downloads directory here. We're going to open up a terminal. If we hit pwd, you see that we are already in the download directory. So I'm just going to paste this command, and this is going to take a hot second. So we're going to run this simulation of a 4x4 Hubbard model. I might take a minute or two. I might end up cutting out a little bit of the video here. We'll see. Okay, so the directory everything's going to be written to was just generated right here. And the simulation is running. You can see a whole bunch of subdirectories have been generated. If you recall, file like bin average measurements will be written to file 100 times during the simulation. So let's see. So you can see here, it's writing each of the bins for some of the global measurements that are getting written to file right here. So once that gets to 100, the simulation will be complete. Let's give it a hot second. But one thing I want to point out while we're waiting for the simulation to end is if we go back to the documentation over here, in addition to this tutorial, and I'll be adding more tutorials in the future, there are a whole bunch of additional examples here for various other types of systems, including examples on how to run simulations averaging over many walkers running in parallel with MPI, how to add checkpointing to a script. These examples have less explanation and exposition than the tutorial does, but you can still download script versions and just run them with some examples of how to run them included. So that can be very helpful. Like here, you can see for this one, it includes a sample command for how to run the simulation. Additionally, another important page in the documentation that I want to point out is the simulation output overview. So these simulations, when you run them, generate a lot of output, and it's a lot of information to parse. And on this page, I try to summarize how to interpret all the output from one of these simulations. So you can see it's broken into sections where like, what's the model summary? Like the model summary tells you how to sort of back out based on the simulation output exactly what the model was that got simulated. It describes uncertainty reporting conventions and various things. So let's take a look at how the simulation's going. We're, let's see, 75, almost 80% of the way through the simulation, so not that much longer. While we're waiting for that to finish, is there anything else I should say about this? There's this page as well. It briefly describes, well, not that briefly, but it describes the class of Hamiltonians that the SmoQyDQMC package currently supports in terms of what it can simulate. So yeah, hopefully none of this is too painful to get up and running on your own system. Let's give this a second longer. The simulation just ended, and there we go. Cool. You can see now we made various types of measurements, the D wave. You can see if we open it, the values of different measured quantities. And that concludes our video. Thank you so much for listening. And that is all.